All right, here we go. Unit 6 final exam review. What I did is I um, put these together closely, so you have to do this on a separate piece of paper. So I'm going to look at these first three questions here. Now, this unit was all about similar triangles and proportional relationships. So here we're just solving some proportions. We can do that just by simple cross multiplication. So here I get that 2x is equal to 1 times 14, which is 14. If I divide both sides by 2, I get that x is equal to 7. On the other side, if I cross multiply, I get 4x times x, which is x squared, and then 3 times 108, which should be 324, I think. Yep, 324. If I divide both sides by 4, I get that x squared is equal to 81. And then if x squared equals 1, if I take the square root of both sides, x must be the square root of 81, or 9. Over here, I'm going to get 3 times k plus 2 is equal to 7 times k minus 2. So this is 3k plus 6 is equal to 7k minus 14. So if I subtract 3k from both sides, I get 4k is equal to 20, or that k is equal to 5. So those are the answers with proportions. Whenever you have a fraction equal a fraction, you can always cross multiply to solve. Now, these proportions are key for when we're looking at similar triangles, because with similar triangles, sides are proportional. And that proportion of one side to the other is what we call the scale factor. So here we have polygons that are similar to one another. And the last two are triangles, and the first one is a pair of pentagons. So we want to write a similarity statement and find that scale factor. The similarity statement is which shapes are similar to the other. So actually, if I look here, notice that angle D is going to be congruent to one another. So these two angles are congruent because they are vertical angles. C is congruent to G. So that means that this top pentagon is actually rotated. If we were to rotate it around, then the C and the G would line up, and then that would fit. So if I look at this top one and I say, I'm going to say this is C, D, E, B, A. So C, D, E, B, A. That's going to be similar. Well, C, as we know, is congruent to G. And D is congruent to D. So if I start here, GD, then I'm just going to keep going around this direction. So GD, FHI. GD, FHI. And these two pentagons are going to be similar. Now the scale factor is going to be one side to the other. So I don't have much other than I have two sides here. I have CD, which is 12, and I have GD, which is 18. If we look, GD is going to be proportional to CD. So if I say that this is going to be 12 to 18, I can reduce that fraction because they both have a common factor of 3. Actually, they have a common factor of 6. So I can say this is 2 to 3. And so this is the scale factor. So hopefully that was similar enough. Now for your final exam, I'm not going to have pentagons. We're going to be looking at triangles since we spent most of the year talking about triangles. However, this is still a really good problem to highlight the relationship of similarity and how in similar polygons, triangles included, sides are proportional, and that proportionality is the scale factor, and angles are congruent. If we look at this second one here, 8, there's actually two triangles on top of each other. So what sometimes helps is if I rewrite these two triangles. So that's PRQ, and the larger one is PTS. Already running out of room here. I'd see that PQ is 2x plus 2, and RQ is going to be 2x. TS is 15, and PS, this whole distance here, is 2x plus 2 plus 6. So that's actually going to be 2x plus 8. I can set up a proportional relationship between these sides, since RQ to TS is going to equal PQ to TS. So 2x to 15 is equal to 2x plus 2 over 2x plus 8. Actually, what I can do, if you notice, 2, 2, 2, 8, this second fraction, all these terms have a common factor of 2, so I can actually reduce that. So I get 2x over 15 is equal to x plus 1 over x plus 4. And the reason for that, again, I factor out a 2 from the first, I factor out a 2 from the denominator, and you can see that these 2's cancel out, and it leaves me with this. So now I can cross multiply, and again, I'm going to get 2x squared plus 8x is equal to 15x plus 15. Now here, because we have this x squared and a single x, this is going to give me a quadratic. So whenever you have a quadratic, you want to set that equal to 0. So we get 2x squared minus 7x minus 15 is equal to 0. With this, we want to factor and we want to solve for x. Now, it's important to know for your final exam, I'm not going to put quadratics on there. You will need to look at quadratics next year, so that's one of the reasons we're focusing now on this. But if this part is over your head, don't stress about it too much, because this will not be on your final exam. Again, these similarities, the similar polygons, the scale factor, that's the important part. But anyway, if I were to factor this, continuing on with this problem, we get 2x and x, and then we need two factors of 15 that add up to get 7. So if I actually do this, I get 10x plus, negative 10x plus 3x would give me negative 7x in the middle. So I set these equal to each other, and I get x is equal to negative 3 halves, x is equal to 5. X can't be a negative value in here, so x is just 5. So if x is 5, that means that this side is 10. And so if I have 10 to 15, then the scale factor is 10 to 15, which we can reduce, again, to 2 to 3. So the scale factor is 2 to 3. Now, we didn't write the similarity statement, but we could absolutely do that first. And that is going to be that triangle PRQ is similar to triangle PTS. There's my similarity statement. And again, to get that scale factor, I need it to find x. I can't just leave the scale factor as 2x to 15 or 2x plus 2 to 2x plus 8. I need it to actually have values. So that's why I need it to solve for x. But again, for your final exam, you may need to do this, but there will not be a quadratic involved. So if anything, below here confuses you, that's okay for your final exam, because I'm not going to put that there. All right, now the next one, number 9, we can see similar triangles. Keep in mind, these two are going to be vertical. So actually, just like this number 7, where this pentagon is rotated around, this second triangle is also rotated around. So if we look at the similarity statement, I can say that triangle AMD, that's going to be similar, if I rotate this around, to CMB. Notice with these parallel lines here, angle B is going to be congruent to angle D. because these are alternate interior angles. So D and B must be in the same position. So then I want to set up a proportion to find the scale factor. Well, again, I'm going to have AM, which is 25. So AM to CN, which is x plus 20, is going to equal MD, negative 3x, to MB, which is 12. Now again, unfortunately for this one, I am going to have a quadratic. So setting this up and solving for x, that's great. If you can do that, perfect. And we will have some other problems like this on this review packet, but solving a quadratic will not be on your final exam. So anyway, if I do multiply this out, I get 25 times 12, which is 300, and then negative 3x squared minus 60x. Everything has a factor of 3, so I can actually divide the whole thing by negative 3. And so that actually leaves me with a negative 100 is equal to x squared plus 20x. If I add 100 to both sides, I get 0 is equal to x squared plus 20x plus 100. So when I factor this, I get x plus 10 times x plus 10. So I need to set this equal to 0. So x plus 10 equals 0. So x equals negative 10. Actually, if I look, that works out because if I plug in x, I'm going to have positive numbers. And so I can use this and I could say, all right, well, my scale factor, is going to be negative 3 times negative 10, which is 30 over 12. Again, they both have a common factor of 6. So this is going to be 5 to 2. And that is the scale factor. And this is the similarity statement. So again, 8 and 9, they're difficult because they involve this quadratic. But as long as you understand the similarity statement and the scale factor, then you're set for the final exam. And there are definitely more examples, especially on this sheet, where we don't have a quadratic to solve. So now for the next set of problems, this is not given whether these are proportional or whether these are similar or not. So we need to actually find out. And so for the first one, I'm given 3 sides here. Now remember, there are theorems to show similarity. So we can show side, side, side if we can show that these 3 sides are proportional to one another. So if I go from this large to this small, I get 12 to 6 should equal 10 to 5, which should equal 6 to 3. Well, if I reduce all these fractions, I get 2 to 1 all around. This is the scale factor, and you can see that this scale factor is the same for all sets of sides. So, are these 2 triangles similar? Yes, because side, 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 all 3 pairs of sides are proportional to one another. As opposed to number 11, if I look here, no, because the angles are not congruent. So remember, in order for triangles to be similar, sides must be proportional and angles must be congruent. So here I'm not given any information about these sides. However, because these 2 angles are different, there's no way that these these triangles can be similar. And similarly with number 12, we have these parallel lines. So we can see that E is congruent to C, D is congruent to B because these are corresponding angles, and A obviously equals itself. So yes, triangle AED is similar to triangle ACB because of angle, angle. That's the theorem there, where the 2 angles are congruent. Now, of course, we know the third angle is congruent, but the theorem says angle because if two sides are congruent, by default, the third must be congruent. So that is explaining that. So we either set up proportions or look at the angles to figure out if triangles are similar or not. All right, here we have a problem where we're just plugging in values for this, and I wonder if I can copy this and use it multiple times. Actually, yes, I think I can. So bear with me for 1 second here. Nope, that's not what I want. Okay, so a little bit pixelated, but so for these three problems here, we have this same triangle repeated for each of them. So if I'm looking at number 13 first, there we go. Number 13, I want to find kj, so this little sliver there. If GH is 12, HI is 4, and GJ, so this whole distance there, is 8. Well, this whole distance here is 16. So already we know that this triangle has these two triangles, and they're going to be similar because of, again, angle with these corresponding angles. So it means the sides must be proportional. So if I look at these two triangles, I'm going to have 16 to 8. And that's perfect. So if I look and I say, all right, this side is 16 and this is 8. So if I want to say, well, what's this going to be, this small triangle? Well, the scale factor from the small triangle to the big triangle is going to be 8 to 16. So actually, no. We can do this a better way. I'm going to write out two triangles. So I'm going to write out G, K, H, and triangle G, J, I. Here, I know that GJ, again, is 8. GI is 16. GH is 12. And so GK, well, I'm going to call that X. And so here I can see that X to 8 is equal to 12 to 16. If I multiply across, I get that 16 is equal to 8 times 12, which is 96. So 16x is equal to 96. So if I divide that by 16, I get that x is equal to 6. So that means that this distance here is 6. So if the whole side is 8 and gk is equal to 6, then kj must equal 8 minus 6, which is 2. All right, so for the next one here, I can see that gh is equal to 7, kj is equal to 6 this time around, and gi is equal to 14. I want to find gk. Well, again, if gh is 7, the whole side is 14, that means that this distance is also 7. So if I, again, want to visualize two different triangles, I can write GKH and GJI. GI, again, is 14. GJ, I'll skip that for now, but GH is going to be 7. And GK is my unknown X. So GJ, if GK is X, then GJ is going to be X plus 6. So now the proportion that I can set up is X to X plus 6 equals 7 to 14. So I get that 14x is equal to 7x plus 42. So 7x is equal to 42. So x is equal to, 6 again. And that's actually what we're looking for this time. X is actually GK, so GK is equal to 6, which is great. And then finally here, I get the GI, so again, this whole side is equal to 9. GK is equal to 6, and KJ is equal to 4. I want to find GI, GH is equal to 9. I want to find GI. GH is equal to 9. Well, if I look here, I can see that GJ would be equal to 10. So it might help me one last time to write out these two triangles, GKH for my small one, and GJI for my larger one. GH is going to be 9. GK is going to be 6. GH, that's what I want to figure out, so I can skip that for now. And then GJ is going to be 10. So actually what I can do is I can call GI X. Just bear in mind that once I get X, I'm going to need to subtract 9 to get HI. So if I set a proportion, I get 6 to 10 equals 9 to X. So this gives me 6X is equal to 90. And so if I divide that by 6, I get that X is equal to 15. But again, that's this whole distance, GI. So if GI is 15 and GH is 9, that must mean that HI is equal to 6, which is 15 minus 9. So a bunch of different problems here. We can see that proportion. We can see setting up the proportions. Again, this is more in line of what to expect for your final exam. No quadratics. But again, if you can set up the proportions, you're fine. All right, and then these two, we want to find the perimeter. Well, in order to find the perimeter, we need to find all of these sides. So here we want to find the perimeter of DEF, but we only know one side. However, we can see that EF is similar to CB. So that means that 10 to 14 is the scale factor. That's the same as 5 to 7. So if I say, let's find DE first, DE corresponds to AC, DE AC. So that means that x to 7 is equal to 14 to 10, or this 7 to 5. So I get that 5x is equal to 49. So x is going to be 9.8. So this distance here, 9.8. Again, I can do the same thing with this DF, and I can see that that's proportional to AB. So y to 13 is equal to, again, I can do the same 7 to 5. And 13 times 7 is 91. So I get 91 is equal to 5y. And if I divide that by 5, I get that y is equal to 18.2. So then the perimeter is going to be equal to 18.2 plus 9.8 plus 14. And so 18.2 plus 9.8 plus 14 is equal to 42. And that's one way to do it, and that's great. Didn't really like that way? I got a better way for you. So again, we can see the scale factor here is 10 to 14, right? So 10 to 14, we know that is 5 to 7. Well, we don't need to find the other sides because we know that this perimeter here is 20. 7 plus 13 is 20 plus 10. We know the perimeter here is 30. Silly me. Perimeter here is 30. So that means that 5 to 7, which is the scale factor, is equal to 30 to x. The perimeter follows the same scale factor. So that means that 5x is equal to 210. And if I divide 210 by 5, I get that the perimeter is equal to 42. Pretty nice, right? I didn't need to find each individual side in order to find the perimeter because parts of similar triangles are proportional, not just the sides. The perimeters are also going to be perimeter to the same scale factor. So if I look at number 7, I can see I got myself a little bit of a problem here because I have these two right triangles and I only know one side for this third one. So that's going to be a lot of math. However, if I look at this and I can see angle M is equal to angle M. So if I have triangle AMC, this is actually going to be similar because angle M is equal to angle M, and that's going to be C, and this is going to be B. There are my two right triangles. Notice that this hypotenuse here, AC, is also this hypotenuse here. So there's going to be some math that we can do in order to figure this out. So let's find some of these sides so we can find a reliable scale factor. So first off this is a right triangle. I can see that this side is 6, the hypotenuse is 10. So that means that x squared plus 6 squared is equal to 10 squared. So x squared plus 36 is equal to 100. So x squared is equal to 64, which means x is equal to 8. So this side AM, this is equal to 8. Well, again, if you look at these two triangles, AMC and yeah, sorry about that. So actually what we probably want to do now is, because we're looking for ABC as opposed to the others, so we want to find what these are. So angle A is congruent to angle A, angle B is congruent to angle B. So we can say if we have triangle ACB and we have triangle AMC, ACB, AMC, these are going to be similar. And so if we know that AM is 8, AC is 10, and MC is 6, we can see that we have AC to be 10. So we have, again, this nice similarity statement, and we have this nice proportion. So this perimeter here is going to equal 8 plus 6 plus 10, which is 24. Now the scale factor from AMC to ABC is going to be 8 to 10 because we have these two sides now. So, 8 to 10 is equal to perimeter, which is 24, to perimeter there, which is x. So I get 8x is equal to 240. So x is going to be equal to 30. And this is the perimeter of that triangle ABC. So again, it helps by drawing a picture so we can see what's there. And once we know we have at least one side, we can set up that proportional statement, that scale factor, and set the perimeters proportional. All right, now we're off that first page, finally, and we can look at these. So this first theorem is about parallel lines, or a parallel line cutting through a triangle. We can make two triangles and set a proportion However, we can also say that these individual sides are proportional. So when we have this parallel line cut through, there's a theorem that we went over that says that the segments of the sides are proportional. So 5 to 3 is going to be equal to 10 to 2x minus 10, side to side, side to side. If I cross multiply, I get 10x minus 50. 10x minus 50 is equal to 30. If I add 50 to both sides, I get 10x is equal to 80. So x is equal to 8. Done. I didn't need to break this up into two triangles because I know I have parallel lines. Number 18, I have 12 to 15 is equal to 16 to 2x plus 6. Actually, what I'm going to do here, because I don't really enjoy multiplying large numbers, 12 to 15 I can reduce to 4 to 5 because they have a common factor of 3. And 16, 2, and 6 all have a common factor of 2. So I can divide everything there by 2. Now I have easier numbers to multiply. If you still do this with the original numbers, you get the same answer. But now I can multiply this all in my head to get 4x plus 12 is equal to 40. I get 4x is equal to 40 minus 12, which is 28. So x is equal to 7. Again, no need to break this up into two triangles. Okay, we also have this angle bisector theorem. When we have an angle bisector, the sides are going to be proportional to the other sides. And I'll show you what I mean in a second. This one's a little bit more algebraic, so I'm actually going to start with number 20. Number 20, if I look 15 to 35, those are the two sides of the angle bisectors. So 15 to 35 is going to equal 2x minus 8 to 28. And actually, you can kind of see that they make corresponding sides. So again, 15 over 35 can be reduced to 5 over 7. And these all have common factor of 2, so I get x minus 4 over 14. A little bit nicer numbers to multiply. 14 times 5, of course, being 70. So 70 is equal to 7x minus 4. And if I add 4 to both sides, I get 74 is equal to 7x. So 74 divided by 7 is just going to be 74 over 7. Over here, if this side is 2x minus 8, this side here is going to be 11 minus 2x minus 8. Distribute the negative, so I get 11 minus 2x plus 8. 11 plus 8 is actually 19 minus 2x. So again, I can set my proportion as 19 minus 2x to 2x minus 8 is equal to 14 to 8. 14 to 8, again, I can divide those both by 2. Oops. To get 7 to 4. 7 to 4 is equal to 19 minus 2x over 2x minus 8. Unfortunately, nothing I can do there. So 19 times 4 is going to be 76. So I get 76 minus 8x is equal to 14x minus 56. I can add 8 to both sides. So if I add 8 to both sides, I get 22x. And if I add the 56 to both sides, 76 plus 56 is 132. And so 132 divided by 22 gives me that x is equal to 6. So nice proportions there. Right, and of course, all these rules apply for other polygons as well. So here, we know that these are all going to be proportional. So I can just say that 12 to 3, so 12 to 3 equals 20 to x minus 6, just like a triangle. Don't let this 5 minus 3 bother you. We can ignore that. And so we get 12x minus 72 equals 60. So 12x is equal to 132. So x is equal to 6. Sorry, 11. I was thinking about 6 from the other one. 11. Nice. And for the next one, again, 16 to 2x, 16 to 2x equals 32 to 40. I can clean up this fraction. I didn't in the last one, but here I can. So 8 over x, reducing this by 2. Reducing this by 8 gives me 425. So I get 40 is equal to 4x. So x equals 10. Okay. And here, we want to state if these are similar or not. Well, we can see that if this is 50 and this is 50, remember in parallelograms, corresponding angles are supplementary, so that's going to be 130, and that means that this is going to be 50. So we can see that the angles are all congruent, but are the sides proportional? Well, 48 to 40 must be equal to 42 to 35. And so 48 to 40, that reduces to 6 over 5 as a fraction. And then 42 to 35 reduces to 6 over 5. So there's a proportion there, right? So because they have this scale factor, yes, they are similar. And that's all I need to do there. 24, again, I can see that these angles are congruent. So I need all the different pairs. So 14, 6 to 4 must equal 13 to 5, which must equal 24 to 8. Well, already I can see that 24 to 8 is 3 to 1. 5 times 3 is 15, not 13. So this actually does not equal 13 to 5 even. So no, these are not similar. Despite the angles being congruent, the sides are not proportional. So no, these are not similar. 25, again, if this angle is equal to that angle, these inside of a parallelogram are going to be supplementary. So all these angles are going to be congruent. So let's check out this proportion again. So 15 to 20. So 15 to 20 should equal 18 to 32. Well, 15 to 20, I can reduce that to 3 to 4. And then if I divide these by 6, because they have a common factor of 6, I get 3 to 5. So unfortunately here, these are not the same. Actually, I can only reduce that by 2, so 9 over 16. And unfortunately, these are not the same. So again, no, these are not similar. More parallelograms in number 26. And actually, if this is 130, this must be 50. So since this angle is 40, already I don't have to find any proportions. I can see that these angles are not congruent. So I know that no, these are not similar. And woo, that's it. So a lot to do there and a lot to review. The key being proportional parts of similar triangles. But don't worry about quadratics. So if you can do these problems and not worry about the quadratics, then you are in really good shape for the final exam.